We're simply asked here to define linear momentum. So linear momentum P is defined as the product of an object's mass and its velocity. Thus, P equals mv. So if you notice some of the tricks that we did here, whenever we mentioned a quantity in words, we put its variable in parentheses after it. And we end with explaining what the formula is. Now we're asked to do the same thing for impulse. Impulse, I, is defined as the product of the average force, F bar, and the time over which the force is applied, delta t, and is equal to the change in momentum of the object body. Thus, I equals F bar delta t. So we did the similar thing with the terms, and we got to thus the formula here. We also went on to explain really what it is, which is the change in momentum. Third question, explain whether it is momentum and impulse are scalar or vector quantities. Well, when we look at the two of those, P equals mv. Velocity is a vector. It could be positive or negative, and momentum then is a vector. It could have positive and negative momentum. The impulse is F bar delta t. Force is a vector, which could be positive or negative, which means that the impulse, the change in momentum received by the other object, could be positive or negative. So, momentum and impulse are both vector quantities because both have a magnitude and direction, the latter of which is determined which determined by the direction of the velocity, a vector quantity, and the average force, a vector quantity, respectively. Of course, respectively refers to momentum with velocity and impulse with average force. His next question is worth 5 points. And it says, by reference of Newton's laws of motion. Let's pause right there and specify those. Newton's first law is the law of inertia, which is the bodies want to preserve their current velocity. Newton's second law is that the net force is equal to the rate of change of momentum. Newton's third law is the consequence of those two, and it states that for every force, there is an equal and opposite force. So those are Newton's three laws. All right, referencing those laws, deduce that when two particles collide, the momentum is conserved. Momentum conservation is P0 equals P. The total momentum is conserved or remains constant. All right, so Newton's laws of motion, two particles collide. Well, two particles collide, there are forces involved, and there are changes in momentum. So we want to start there. Newton's second law states that F net is equal to the rate of change in momentum. And that is F net equals delta P over delta T. Newton's third law states that when two objects collide, the forces the objects experience will be equal in magnitude and opposite in direction. Both particles are in contact with each other for equal amounts of time. Delta T, because it's not possible for one to be in contact with the other without the other being in contact with the first. So if the forces are equal and opposite, and the delta T's are equal, then the delta P's are equal and opposite. And by that we mean one gains momentum and the other loses the same amount. In this situation, the total momentum will remain the same. Thus, momentum is conserved. And so in this question, we're asked first Newton's laws of momentum, or Newton's laws of motion. We lay those out to make sure that we're including them. We want to know about collisions, and we want to show the momentum is conserved, so we get our momentum conserved in there. So we have momentum conserved. we have Newton's second law, Newton's third law. We made no mention of Newton's first law, but it actually also doesn't apply in this particular case. And we went on to explain each one methodically, step by step by step by step.